John Stuart Mill says in his Principles of Political Economy, "It is questionable if all the mechanical inventions yet made have lightened the day's toil of any human being." That is, however, by no means the aim of the capitalistic application of machinery. Like every other increase in the productiveness of labor, machinery is intended to cheapen commodities, and by shortening that portion of the working day in which the laborer works for himself, to lengthen the other portion that he gives without an equivalent to the capitalist. In short, it is a means for producing surplus value. In manufacture, the revolution in the mode of production begins with the labor power. In modern industry, it begins with the instruments of labor. Our first inquiry, then, is how the instruments of labor are converted from tools into machines, or what is the difference between a machine and the implements of a handicraft. We are only concerned here with striking and general characteristics, for epochs in the history of society are no more separated from each other by hard and fast lines of demarcation than are geological epochs. Mathematicians and mechanicians, and in this they are followed by a few English economists, call a tool a simple machine, and a machine a complex tool. They see no essential difference between them, and even give the name of machine to the simple mechanical powers, the lever, the inclined plane, the screw, the wedge, and as a matter of fact, every machine is a combination of those simple powers, no matter how they may be disguised. From the economic standpoint, this explanation is worth nothing, because the historical element is wanting. Another explanation of the difference between tool and machine is that in the case of a tool, man is the motive power, while the motive power of a machine is something different from man, as for instance, an animal, water, wind, and so on. According to this, a plow drawn by oxen, which is a contrivance common to the most different epochs, would be a machine, while Clausen's circular loom, which, worked by a single laborer, weaves picks per minute, would be a mere tool. Nay, this very loom, though a tool when worked by hand, would, if worked by steam, be a machine. And since the application of animal power is one of man's earliest inventions, production by machinery would have preceded production by handicraft. When John Wyatt brought out his spinning machine and began the industrial revolution of the 8th century, not a word did he say about an ass driving it instead of a man, and yet this part fell to the ass. He described it as a machine to spin without fingers. All fully developed machinery consists of three essentially different parts: the motor mechanism, the transmitting mechanism, and finally the tool or working machine. The motor mechanism is that which puts the whole in motion. It either generates its own motive power, like the steam engine, the caloric engine, the electromagnetic machine, or it receives its impulse from some already existing natural force, like the water wheel from a head of water, the windmill from wind, and the transmitting mechanism, composed of flywheels, shafting, toothed wheels, pulleys, straps, ropes, bands, pinions, and gearing of the most varied kinds, regulates the motion, changes its form where necessary, as for instance, from linear to circular, and divides and distributes it among the working machine. These two first parts of the whole mechanism are there, solely for putting the working machines in motion, by means of which motion the subject of labor is seized upon and modified as desired. The tool or working machine is that part of the machinery with which the industrial revolution of the 8th century started. And to this day it constantly serves as such a starting point, whenever a handicraft or a manufacture is turned into an industry carried on by machinery. On a closer examination of the working machine proper, we find in it, as a general rule, though often, no doubt, under very altered forms, the apparatus and tools used by the handicraftsman or manufacturing workman, with this difference, that instead of being human implements, they are the implements of a mechanism or mechanical implements. Either the entire machine is only a more or less altered mechanical edition of the old handicraft tool, as for instance, the power loom or the working parts fitted in the frame of the machine are old acquaintances, as spindles are in a mule, needles in a stocking loom, saws in a sewing machine, and knives in a chopping machine. The distinction between these tools and the body proper of the machine exists from their very birth, for they continue for the most part to be produced by handicraft or by manufacture, and are afterwards fitted into the body of the machine, which is the product of machinery. The machine proper is therefore a mechanism that, after being set in motion, performs with its tools the same operations that were formerly done by the workman with similar tools. Whether the motive power is derived from man or from some other machine makes no difference in this respect. From the moment that the tool proper is taken from man and fitted into a mechanism, a machine takes the place of a mere implement. The difference strikes one at once, even in those cases where man himself continues to be the prime mover. The number of implements that he himself can use simultaneously is limited by the number of his own natural instruments of production, by the number of his bodily organs. In Germany, they tried at first to make one spinner work two spinning wheels, that is, to work simultaneously with both hands and both feet. This was too difficult. Later, a treadle spinning wheel with two spindles was invented, but adepts in spinning, who could spin two threads at once, were almost as scarce as two-headed men. The jenny, on the other hand, even at its very birth, spun with spindles, and the stocking loom knits with many thousand needles at once. The number of tools that a machine can bring into play simultaneously is from the very first emancipated from the organic limits that hedge in the tools of a handy craftsman. In many manual implements, the distinction between man as mere motive power and man as the workman or operator properly so called is brought into striking contrast. For instance, the foot is merely the prime mover of the spinning wheel, while the hand, working with the spindle and drawing and twisting, performs the real operation of spinning. It is this last part of the handy craftsman's implement that is first seized upon by the Industrial Revolution, leaving to the workman, in addition to his new labor of watching the machine with his eyes and correcting its mistakes with his hands, the merely mechanical part of being the moving power. On the other hand, implements, in regard to which man has always acted as a simple motive power, as for instance, by turning the crank of a mill, by pumping, by moving up and down the arm of a bellows, by pounding with a mortar, and such implements soon call for the application of animals, water and wind as motive powers. Here and there, long before the period of manufacture, and also to some extent during that period, these implements pass over into machines, but without creating any revolution in the mode of production. It becomes evident in the period of modern industry that these implements, even under their form of manual tools, are already machine. For instance, the pumps with which the Dutch emptied the Lake of Haarlem were constructed on the principle of ordinary pumps, the only difference being that their pistons were driven by cyclopean steam engines instead of by men. The common and very imperfect bellows of the blacksmith is, in England, occasionally converted into a blowing engine by connecting its arm with a steam engine. The steam engine itself, such as it was at its invention during the manufacturing period at the close of the 8th century, and such as it continued to be down to, did not give rise to any industrial revolution. It was, on the contrary, the invention of machines that made a revolution in the form of steam engines necessary. As soon as man, instead of working with an implement on the subject of his labor, becomes merely the motive power of an implement machine, it is a mere accident that motive power takes the disguise of human muscle, and it may equally well take the form of wind, water, or steam. Of course, this does not prevent such a change of form from producing great technical alterations in the mechanism that was originally constructed to be driven by man alone. Nowadays, all machines that have their way to make, such as sewing machines, bread-making machines, and are, unless from their very nature their use on a small scale is excluded, constructed to be driven both by human and by purely mechanical motive power. The machine, which is the starting point of the Industrial Revolution, supersedes the workman, who handles a single tool, by a mechanism operating with a number of similar tools, and set in motion by a single motive power, whatever the form of that power may be. Here we have the machine, but only as an elementary factor of production by machinery. Increase in the size of the machine, and in the number of its working tools, calls for a more massive mechanism to drive it, and this mechanism requires, in order to overcome its resistance, a mightier moving power than that of man, apart from the fact that man is a very imperfect instrument for producing uniform continued motion. But assuming that he is acting simply as a motor, that a machine has taken the place of his tool, it is evident that he can be replaced by natural forces. Of all the great motors handed down from the manufacturing period, horsepower is the worst, partly because a horse has a head of his own, partly because he is costly, and the extent to which he is applicable in factories is very restricted. Nevertheless, the horse was extensively used during the infancy of modern industry. This is proved as well by the complaints of contemporary agriculturists as by the term horsepower, which has survived to this day as an expression for mechanical force. Wind was too inconstant and uncontrollable, and besides, in England, the birthplace of modern industry, the use of water power preponderated even during the manufacturing period. In the 8th century, attempts had already been made to turn 2 pairs of millstones with a single water wheel. But the increased size of the gearing was too much for the water power, which had now become insufficient, and this was one of the circumstances that led to a more accurate investigation of the laws of friction. In the same way, the irregularity caused by the motive power in mills that were put in motion by pushing and pulling a lever led to the theory and the application of the flywheel, which afterwards plays so important a part in modern industry. In this way, during the manufacturing period, were developed the first scientific and technical elements of modern mechanical industry. Arkwright's throstle spinning mill was from the very first turned by water. But for all that, the use of water as the predominant motive power was beset with difficulties. It could not be increased at will, it failed at certain seasons of the year, and above all, it was essentially local. Until the invention of Watt's second and so-called double-acting steam engine was a prime mover found that begot its own force by the consumption of coal and water, whose power was entirely under man's control, that was mobile and a means of locomotion, that was urban and not, like the water wheel, rural, that permitted production to be concentrated in towns instead of, like the water wheels, being scattered up and down the country, that was of universal technical application. Relatively speaking, little affected in its choice of residence by local circumstances. The greatness of Watt's genius showed itself in the specification of the patent that he took out in April. In that specification, his steam engine is described, not as an invention for a specific purpose, but as an agent universally applicable in mechanical industry. In it he points out applications, many of which, as for instance the steam hammer, were not introduced till half a century later. Nevertheless, he doubted the use of steam engines in navigation. His successors, Boulton and Watt, sent to the exhibition of steam engines of colossal size for ocean steamers. As soon as tools had been converted from being manual implements of man into implements of a mechanical apparatus, of a machine, the motive mechanism also acquired an independent form, entirely emancipated from the restraints of human strength. Thereupon the individual machine, that we have hitherto been considering, sinks into a mere factor in production by machinery. One motive mechanism was now able to drive many machines at once. The motive mechanism grows with the number of the machines that are turned simultaneously, and the transmitting mechanism becomes a wide-spreading apparatus. We now proceed to distinguish the cooperation of a number of machines of one kind from a complex system of machinery. In the one case, the product is entirely made by a single machine, which performs all the various operations previously done by one handicraftsman with his tool, as for instance, by a weaver with his loom, or by several handicraftsmen successively, either separately or as members of a system of manufacture. For example, in the manufacture of envelopes, one man folded the paper with the folder, another laid on the gum, a third turned the flap over, on which the device is impressed, a fourth embossed the device, and so on, and for each of these operations the envelope had to change hands. One single envelope machine now performs all these operations at once, and makes more than envelopes in an hour. In the London exhibition there was an American machine for making paper cornets. It cut the paper, pasted, folded, and finished in a minute. Here, the whole process, which, when carried on as manufacture, was split up into, and carried out by, a series of operations, is completed by a single machine, working a combination of various tools. Now, whether such a machine be merely a reproduction of a complicated manual implement, or a combination of various simple implements specialized by manufacture, in either case, in the factory, in the workshop in which machinery alone is used, we meet again with simple cooperation, and leaving the workman out of consideration for the moment, this cooperation presents itself to us, in the first instance, as the conglomeration in one place of similar and simultaneously acting machines. Thus, a weaving factory is constituted of a number of power looms, working side by side, and a sewing factory of a number of sewing machines all in the same building. But there is here a technical oneness in the whole system, owing to all the machines receiving their impulse simultaneously, and in an equal degree, from the pulsations of the common prime mover, by the intermediary of the transmitting mechanism. And this mechanism, to a certain extent, is also common to them all, since only particular ramifications of it branch off to each machine. Just as a number of tools, then, form the organs of a machine, so a number of machines of one kind constitute the organs of the motive mechanism. A real machinery system, however, does not take the place of these independent machines until the subject of labor goes through a connected series of detailed processes that are carried out by a chain of machines of various kinds, the one supplementing the other. Here we have again the cooperation by division of labor that characterizes manufacture, only now it is a combination of detail machines. The special tools of the various detail workmen, such as those of the beaters, cambers, spinners, and in the woolen manufacture, are now transformed into the tools of specialized machines, each machine constituting a special organ with a special function in the system. In those branches of industry in which the machinery system is first introduced, manufacture itself furnishes, in a general way, the natural basis for the division and consequent organization of the process of production. Nevertheless, an essential difference at once manifests itself. In manufacture, it is the workmen who, with their manual implements, must, either singly or in groups, carry on each particular detail process. If on the one hand the workman becomes adapted to the process, on the other, the process was previously made suitable to the workman. This subjective principle of the division of labor no longer exists in production by machinery. Here, the process as a whole is examined objectively, in itself, that is to say, without regard to the question of its execution by human hands. It is analyzed into its constituent phases, and the problem, how to execute each detail process and bind them all into a whole, is solved by the aid of machines, chemistry. But of course, in this case also, theory must be perfected by accumulated experience on a large scale. Each detail machine supplies raw material to the machine next in order, and since they are all working at the same time, the product is always going through the various stages of its fabrication, and is also constantly in a state of transition from one phase to another. Just as in manufacture, the direct cooperation of the detail laborers establishes a numerical proportion between the special groups, so in an organized system of machinery, where one detail machine is constantly kept employed by another, a fixed relation is established between their numbers, their size, and their speed. Collective machine, now an organized system of various kinds of single machines, and of groups of single machines, becomes more and more perfect, the more the process as a whole becomes a continuous one, the less the raw material is interrupted in its passage from its first phase to its last. In other words, the more its passage from one phase to another is effected, not by the hand of man, but by the machinery itself. In manufacture, the isolation of each detail process is a condition imposed by the nature of division of labor, but in the fully developed factory, the continuity of those processes is, on the contrary, imperative. A system of machinery, whether it reposes on the mere cooperation of similar machines, as in weaving, or on a combination of different machines, as in spinning, constitutes in itself a huge automaton, whenever it is driven by a self-acting prime mover. But although the factory as a whole be driven by its steam engine, yet either some of the individual machines may require the aid of the workmen for some of their movements, or, to enable a machine to do its work, certain parts of it may require to be handled by the workman like a manual tool. This was the case in machine makers' workshops, before the conversion of the slide rest into a self-act. As soon as a machine executes, without man's help, all the movements requisite to elaborate the raw material, needing only attendance from him, we have an automatic system of machinery, and one that is susceptible of constant improvement in its detail. Such improvements as the apparatus that stops a drawing frame whenever a sliver breaks, and the self-acting stop that stops the power loom so soon as the shuttle bobbin is emptied of weft, are quite modern inventions. As an example, both of continuity of production and of the carrying out of the automatic principle, we may take a modern paper mill. In the paper industry generally, we may advantageously study in detail not only the distinctions between modes of production based on different means of production, but also the connection of the social conditions of production with those modes. For the old German papermaking furnishes us with a sample of handicraft production, that of Holland in the H, and of France in the H century, with a sample of manufacturing in the strict sense, and that of modern England, with a sample of automatic fabrication of this article. Besides these, there still exist, in India and China, two distinct antique Asiatic forms of the same industry. An organized system of machines, to which motion is communicated by the transmitting mechanism from a central automaton, is the most developed form of production by machinery. Here we have, in the place of the isolated machine, a mechanical monster whose body fills whole factories, and whose demon power, at first veiled under the slow and measured motions of his giant limbs, at length breaks out into the fast and furious whirl of his countless working organs. There were mules and steam engines before there were any laborers, whose exclusive occupation it was to make mules and steam engines, just as men wore clothes before there were such people as tailors. The inventions of Vaucanson, Arkwright, Watt, and others were, however, practicable only because those inventors found, ready to hand, a considerable number of skilled mechanical workmen placed at their disposal by the manufacturing period. Some of these workmen were independent handicraftsmen of various trades, others were grouped together in manufactures, in which, as before mentioned, division of labor was strictly carried out. As inventions increased in number, and the demand for the newly discovered machines grew larger, the machine-making industry split up, more and more, into numerous independent branches, and division of labor in these manufactures was more and more developed. Here then we see in manufacture the immediate technical foundation of modern industry. Manufacture produced the machinery, by means of which modern industry abolished the handicraft and manufacturing systems in those spheres of production that it first seized upon. Factory system was therefore raised, in the natural course of things, on an inadequate foundation. When the system attained to a certain degree of development, it had to root up this ready-made foundation, which in the meantime had been elaborated on the old lines, and to build up for itself a basis that should correspond to its methods of production. Just as the individual machine retains a dwarfish character, so long as it is worked by the power of man alone, and just as no system of machinery could be properly developed before the steam engine took the place of the earlier motive powers, animals, wind, and even water, so, too, modern industry was crippled in its complete development, so long as its characteristic instrument of production, the machine, owed its existence to personal strength and personal skill, and depended on the muscular development, the keenness of sight, and the cunning of hand, with which the detail workmen in manufactures and the manual laborers in handicrafts wielded their dwarfish implements. Thus, apart from the dearness of the machines made in this way, a circumstance that is ever present to the mind of the capitalist, the expansion of industries carried on by means of machinery, and the invasion by machinery of fresh branches of production, were dependent on the growth of a class of workmen, who, owing to the almost artistic nature of their employment, could increase their numbers only gradually, and not by leaps and bounds. But besides this, at a certain stage of its development, modern industry became technologically incompatible with the basis furnished for it by handicraft and manufacture. Increasing size of the prime movers, of the transmitting mechanism, and of the machines proper, the greater complication, multiformity and regularity of the details of these machines, as they more and more departed from the model of those originally made by manual labor, and acquired a form, untrammeled except by the conditions under which they worked, the perfecting of the automatic system, and the use, every day more unavoidable, of a more refractory material, such as iron instead of wood. The solution of all these problems, which sprang up by the force of circumstances, everywhere met with a stumbling block in the personal restrictions, which even the collective laborer of manufacture could not break through, except to a limited extent. Such machines as the modern hydraulic press, the modern power loom, and the modern carding engine could never have been furnished by manufacture. Radical change in the mode of production in one sphere of industry involves a similar change in other spheres. This happens at first in such branches of industry as are connected together by being separate phases of a process, and yet are isolated by the social division of labor, in such a way that each of them produces an independent commodity. Thus spinning by machinery made weaving by machinery a necessity, and both together made the mechanical and chemical revolution that took place in bleaching, printing, and dyeing imperative. So too, on the other hand, the revolution in cotton spinning called forth the invention of the gin. For separating the seeds from the cotton fiber, it was only by means of this invention that the production of cotton became possible on the enormous scale at present required. But more especially, the revolution in the modes of production of industry and agriculture made necessary a revolution in the general conditions of the social process of production, in the means of communication and of transport. A society whose pivot, to use an expression of Fourier, was agriculture on a small scale, with its subsidiary domestic industries, and the urban handicrafts, the means of communication and transport were so utterly inadequate to the productive requirements of the manufacturing period, with its extended division of social labor, its concentration of the instruments of labor, and of the workmen, and its colonial markets, that they became in fact revolutionized. In the same way, the means of communication and transport handed down from the manufacturing period soon became unbearable trammels on modern industry, with its feverish haste of production, its enormous extent, its constant flinging of capital and labor from one sphere of production into another, and its newly created connections with the markets of the whole world. Hence, apart from the radical changes introduced in the construction of sailing vessels, the means of communication and transport became gradually adapted to the modes of production of mechanical industry, by the creation of a system of river steamers, railways, ocean steamers, and telegraphs. but the huge masses of iron that had now to be forged, to be welded, to be cut, to be bored, and to be shaped, demanded on their part Cyclopean machines, for the construction of which the methods of the manufacturing period were utterly inadequate. Modern industry had therefore itself to take in hand the machine, its characteristic instrument of production, and to construct machines by machine. It was not till it did this that it built up for itself a fitting technical foundation and stood on its own feet. Machinery, simultaneously with the increasing use of it, in the first decades of this century, appropriated by degrees the fabrication of machines proper. But it was only during the decade preceding that the construction of railways and ocean steamers on a stupendous scale called into existence the Cyclopean machines now employed in the construction of prime mover. The most essential condition to the production of machines by machines was a prime mover capable of exerting any amount of force, and yet under perfect control. Such a condition was already supplied by the steam engine. But at the same time it was necessary to produce the geometrically accurate straight lines, planes, circles, cylinders, cones, and spheres required in the detail parts of the machine. This problem Henry Maudslay solved in the first decade of this century by the invention of the slide rest, a tool that was soon made automatic, and in a modified form was applied to other constructive machines besides the lathe, for which it was originally intended. This mechanical appliance replaces, not some particular tool, but the hand itself, which produces a given form by holding and guiding the cutting tool along the iron or other material operated upon. Thus it became possible to produce the forms of the individual parts of machinery, with a degree of ease, accuracy, and speed that no accumulated experience of the hand of the most skilled workman could give. If we now fix our attention on that portion of the machinery employed in the construction of machines, which constitutes the operating tool, we find the manual implements reappearing, but on a Cyclopean scale. The operating part of the boring machine is an immense drill driven by a steam engine. Without this machine, on the other hand, the cylinders of large steam engines and of hydraulic presses could not be made. Mechanical lathe is only a Cyclopean reproduction of the ordinary foot lathe. The planing machine, an iron carpenter, that works on iron with the same tools that the human carpenter employs on wood. The instrument that, on the London wharves, cuts the veneers, is a gigantic razor. The tool of the shearing machine, which shears iron as easily as a tailor's scissors cut cloth, is a monster pair of scissors, and the steam hammer works with an ordinary hammer head, but of such a weight that not Thor himself could wield it. These steam hammers are an invention of Nasmyth, and there is one that weighs over tons and strikes with a vertical fall of feet on an anvil weighing ton. It is mere child's play for it to crush a block of granite into powder, yet it is no less capable of driving, with a succession of light taps, a nail into a piece of soft wood. The implements of labor in the form of machinery necessitate the substitution of natural forces for human force, and the conscious application of science instead of rule of thumb. In manufacture, the organization of the social labor process is purely subjective. It is a combination of detail laborers. In its machinery system, modern industry has a productive organism that is purely objective, in which the laborer becomes a mere appendage to an already existing material condition of production. In simple cooperation, and even in that founded on division of labor, the suppression of the isolated, by the collective, workman still appears to be more or less accidental. Machinery, with a few exceptions to be mentioned later, operates only by means of associated labor, or labor in common. Hence the cooperative character of the labor process is, in the latter case, a technical necessity dictated by the instrument of labor itself.